Hi. Uh, yep. Hi guys. My name is Samuel Jasper. I'm from CSC department. My topic for AIT for essentials of problem solving is on missing numbers. What is missing numbers? Let's say missing numbers. Uh, let's say we are given an array which consists of numbers 1, 2, 4, and 5, and we need to find which number is missing in the array. Like as we know, the array consists of 1, 2, 4, and 5. This is the order of 1 to 5. So, when through manually we can say that the number 3 is missing. So, the number 3 is missing in this array. This is what the missing number is all about. The definition for missing numbers. The missing numbers can break systems like missing a file chunk or a network packet. In coding interviews, it tests your ability to think mathematically and optimize. Missing numbers problem is equal to find a single number that is not present where it should be. Like we have multiple ways to find the missing numbers. The simple way to find the missing number is uh, through this method. We use the simple sum formula idea. The sum of first n natural numbers is sum is equal to n into n plus 1 divided by 2. Then what we need to do is find what the sum should be using the above formula n into n plus 1 divided by 2, and find the sum of the numbers you have, and missing number is equal to total sum minus given array sum. By doing this, we get the missing number as the sum or any other thing. See, here we are given an array or a nums array which consists of numbers 1, 2, 4, and 5. The numbers are from 1 to 5. So the total sum comes up to be 15, 5 into 6 divided by 2, which is mathematical, which can be done manually. And the sum of the given numbers, 1 plus 2 is equal to 3, 3 plus 4, 7, 7 plus 5 is equal to 12. So, like as I have said in the before slide, missing number is equal to total sum minus given array sum. 15 minus 12 gives us the 3, and we know that the 3 is the missing number. Hence, proof. The code for this uh, sum formula is this int missing number vector int reference nums. Vector int is the container which consists of the array and handles the bigger arrays too. Int n is equal to nums, right? Nums dot size means array size plus 1. Int total is equal to n multiplied into n plus 1 and divided by 2. This is a formula that we have discussed earlier. Int sum is equal to 0, and we need to run a for loop int num sum plus is equal to num, and we need to return total minus sum, which is the missing number. 15 minus 12 is equal to 3, and hence we get the 3 as the output. And the other method that we have for finding the missing number is XOR. XOR is one of the famous methods which is used to solve complex problems. Any in the platforms like LeetCode, Codeforces, CodeChef, and etc. The idea of XOR method is let's say we have a number A. A XOR A gives 0. Any number XOR with itself is 0, and any number XOR with 0 also is the number itself. So if we XOR all numbers from 0 to n and XOR all the numbers you have, the missing number will automatically pop up. If you didn't get it, we'll get it. This code for this is this int missing number vector int nums int n is equal to nums dot size, which is the array size. int XOR of all is equal to 0 and XOR of array is equal to 0. And we need to run a for loop from int I is equal to 0 till the arrays till less than or equal to n, which is the array size, and we need to XOR all from I to the array size, and the same for XOR array, and we need to return XOR all of XOR array. Then we will get the we will get the missing number. It is similar to the sum formula. Yeah, the other method that we have for finding the missing number is index placement sorting method. The idea is we need to sort the arrays first, and the numbers should be continuous like 0, 1, 2, 3, 4, and till the end. If at any index the value is not equal to in the index, that index is the missing number. We know that the array index starts from 0, 1, 2, 3, and so forth. So when we compare the given array with the indices, then we will get to know what number is missing. It's yes, that's it. The the code for index placement is so we need to sort. So the sort nems dot begin to nems dot end. This is an STL method in C++ language, and we need to run a for loop from I int I is equal to 0 till the array size, and we need to check the index is equal to is the index value is equal to the array the number in the array. If yes, we need to return I, or else no, and we need to return the nems dot size. If all correct, we need to, or else no. Index mapping, the other method for finding the missing number is index mapping. It is a placement trick without sorting. Normally, it is used when modifying the array is allowed. Your mark numbers by changing values at the corresponding indexes. But for missing numbers, a single one, 0 to n range, the smarter way is to sum of indices versus sum of elements, which handles without sort. It's a super neat trick version. Say we have given an array nums which consists of 3, 0, and 1. We start with the expected sum of indexes from 0 to n. Uh, say 0 plus 1 plus 2 plus 3 is equal to 0. Actual sum of array elements gives us 3 plus 0 plus 1 is equal to 4. Missing number is equal to expected sum minus actual sum. 6 minus 4 is equal to 2. Here what we did is we first we calculate we did add the indices from 0 to n, and and then we did add the elements that are in the array. So when we subtract expected sum, uh, actual sum from expected sum, we get the number. So 2 is a missing number here. The code for this is for index mapping is here. Int missing is equal to and nems dot size, which is array size. I need to run a for loop from int I is equal to 0, I less than size, and missing XOR is equal to I XOR nems dot I return missing. In super simple words, if you want the easiest code, we need to use some method. Most reliable and clever code, we need to use this XOR method, which is which is faster than the easiest code sum method. And if you are a beginner, but if you want the beginner friendly but slower version of the XOR method, you can use the XOR method. But say if you want the advanced code, advanced method and super fast method, you can use index mapping or optimized XOR version. Where do we use this missing number? We use this missing number to file downloads and data transmissions. Files like videos software are often broken into small chunks. Each chunk has a number 0 to n. If a chunk is missing, it causes file corruption. Missing number detection helps re-download the missing chunk. Network packets. When computers send data over a network, data is broken into packets. Packets have sequence numbers. If a packet is missing, because of network loss, you detect it and ask for retransmission. For example, streaming a YouTube video, it detects and fixes simple, smart missing parts automatically. Advantages, you know, some formula is simple and intuitive. The complexity is of big of n, and the space complexity is big of 1. No modifications needed for job method. No overflow. 0 of n time and 0 of 1 space. And it's fast and efficient. Ideal for large data. Sorting method, it is easy to implement. Works with unsorted array. Good for smaller arrays. Index mapping optimized SOA. Better for larger data sets, say YouTube and etc. It is of big of n time, big of one space, and no sorting needed. Disadvantages: some formula. It overflow risk, doesn't handle negative numbers, single missing numbers only. A job method, not intuitive, difficult to understand, harder to read and maintain. Sorting method, big of n log n time, array modification inefficient for larger data sets. Index mapping, array modification needed, repetition confusing for beginners, single missing numbers only. Conclusion: the missing number problem is a fundamental algorithm challenge that often shows up in coding interviews, competitive programming, code forces, for example, real-world applications, systems, data transmission, etc. The core task is to find a single missing number from a sequence of numbers, but how you solve it can vary. Understanding these different methods not only help in solving the problem, but also demonstrates a deep understanding of algorithms, data structures, and optimization techniques. Don't just memorize them, practice with real problems to truly master each approach and know which to use when. Thank you. Thank you.